Hello everyone. Through this video, we are going to discuss the questions of the first exercise 7.1 in the chapter of Permutation and Combination. So here goes the first question. Let us check what the first question says. How many three-digit numbers can be formed from the digits 1, 2, 3, 4 and 5, assuming that number 1, repetition of the digits is allowed. Means in this case, the digits can repeat. And in the second case, repetition of the digits is not allowed. Now let us check how to solve this sum. Let us first consider what are the digits given. Given digits are 1, 2, 3, 4 and 5. So total number of digits is equal to 5. Yes or no? Now case 1, when I consider the first part of this question. So what it says, repetition of the digits is allowed. So actually in this case we have to make a 3-digit number. So we know that in case of a 3-digit number there are 3 places. First one is for ones place, second one is for tens place, and the third one is for hundreds place. Normally when we write 3-digit numbers, say 523, the hundreds place come here. Yes or no? Hundreds place comes here. Then the second place, this place is tens place. This is hundreds place, this is tens place, and this is ones place. Yes or no? But in this case we have to make arrangements. These boxes, these positions I am framing here, it doesn't mean that this will be the numbers here. These are just arrangements. So whenever we consider the places from left hand side also, then also there is no problem. And if we consider the places from the right hand side, then also there is no problem. I mean to say, if suppose I write here ones place, then the second house for tens place, and the third one is for hundreds place, then also there is no problem. And if we start writing hundreds place in the first position, then after in the second position tens, then after in the third position ones, then also there is no problem. Now we already have 5 digits in our hand. So for ones place we can put any one of these digits. Yes or no? If we choose any one of these digits, so how many options do we have for choosing the digits? Of course 5 options are there. Yes or no? 5 digits, so 5 options. So I shall be writing here 5. Now for tens place, one thing we should keep in our mind, that repetition of the digits is allowed. I mean to say, if I write here 2 ones, say in the first position, I mean in ones place I wrote 2. The same thing can be repeated for tens place also. Suppose the ones place I filled up by 2. The tens place also can be filled in by 2. Then the hundreds place can also have the same digit like 2. Because repetition of the digits is allowed. There is no bindings that we have to use only one number in one place. There is nothing like that. Therefore, again I have 5 options for tens place also. Yes or no? Because whatever number I used here, the same number can be repeated in tens place also. Same is the case for hundreds place also. Whatever number, I mean whatever digits I have already used in places of ones place, tens place, the same digit can be written for hundreds place also. So for hundreds place again we have 5 options left in our hand. Now, the most important thing to be noticed here is what? We cannot ignore any one of these three positions. Means ones place is also needed, tens place is also needed, and hundreds place is also needed for framing this 3-digit number. Yes or no? Therefore, of course, fundamental principle of counting we have to apply here, but which part? Fundamental principle of multiplication or fundamental principle of addition? Which one we have to use here? Of course, fundamental principle of multiplication we have to use here, because we need all these three parts: ones place and tens place and hundreds place. This "and" stands for what? Multiplication. Fundamental principle of multiplication, which already I have explained in my previous video. So here in this case, while writing the solution part for Roman 1, for the part Roman 1, how do I have to write? Ones place. Ones place can be filled in how many ways? 5 ways. Then after, tens place can be filled in how many ways? Again 5 ways. Then hundreds place can be filled in 5 ways. So after that, when I apply fundamental principle of counting by fundamental principle of counting, this counting refers to what? Fundamental principle of multiplication, of course. The total number of ways is equal to, we have to multiply these three quantities. Yes or no? So 5 into 5 into 5 ways is equal to, this will be 125 ways. So this is how we have to solve the first part, I mean Roman 1. Let's come to the second part. Repetition of the digits is not allowed. When repetition is not allowed, in that case what do we have to do? Let us check now. Repetition is not allowed means the number which we are using for the first place, I mean the digit which we are using for the first place, that cannot be repeated for the second place. Yes or no? So here we have to write, when repetition of the digits, when repetition of the digits is not allowed, So this is the second point, I mean second part of this question. So how do I write? Of course I have to make 3 boxes here also, and making 3 boxes, what do I get? I have to write in this way. Of course I have to get 3 boxes here also. This is ones place, this is tens place, and this is hundreds place. So here in this case, of course we are having 5 options left in our hand. The digits are given to be 1, 2, 3, 4, 5 like this, as we had considered earlier. The digits are 1, 2, 3, 4 and 5. Then total number of digits are given to be 5. So we are having 5 options in our hand. So here in this case, for the second part, if I write here 5, means if ones place can be filled in 5 ways, I can write 5 here. Now for tens place, actually whatever number I have, whatever digit I have used here, as it is mentioned that repetition of the digits is not allowed, means whatever digit I have used in ones place, the same digit cannot be repeated in tens place or hundreds place. Therefore, suppose out of 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, these are the digits given to us. Out of these, I have chosen 2 for this position. If I write 2 in the first place, I mean for ones place, how many options left in my hand for the second part, I mean for tens place? Of course, these 4 numbers left, these 4 digits left, yes or no? So for tens place, there are 4 options in my hand. Then after, whatever number I shall be using in tens place, the same number I shall not be able to repeat for hundreds place. I mean to say the digits what are already filled in ones place and tens place, those digits cannot be repeated for hundreds place. So these, suppose in this position I consider 3. Suppose 3 I have chosen for this place, tens place. So how many options are left? 1, 4 and 5. These 3 options are left in my hand to fill in the hundreds place. So I can put here 3. Therefore, and this actually this is the way to fill up these 3 positions in this case when repetition of the digits is not allowed. Now the proper way to write it down. This is the way. Ones place can be filled in 5 ways. Then after, tens place can be filled in how many ways? 4 ways. Then hundreds place can be filled in 3 ways. Therefore, in this case also, ones place and tens place and hundreds place, all these 3 are the requirements for solving this sum. So of course we have to proceed with fundamental principle of multiplication, because all these 3 parts we have to take into account. Means this will be joined together by the conjunction AND. Means ones place and tens place and hundreds place. Therefore, of course, we have to use fundamental principle of multiplication. So how do I write? By fundamental principle of counting. Why am I writing counting? Because multiplication, fundamental principle of multiplication comes under fundamental principle of counting only. The total number of ways is equal to, how do I write? 5 into 4 into 3. The answer will be 5 4 ja 20, 20 into 3, it is 60. 60 ways, and that's your answer. Here goes the second question of the exercise. What is given in this question? How many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5 and 6 if the digits can be repeated? Means repetition is allowed here, but there is one restriction. That is what? We have to form 3-digit numbers, but what kind of numbers? Even numbers. That means the ones place should always be an even number. Means ones place can be filled only with those numbers which are divisible by 2. So in the solution part, let us first write down what are the digits given. Given digits are 1, 2, 3, 4, 5 and 6. So total number of digits is equal to 6 here. And one more thing we have to write down, that is what? Total number of even digits, because this will be required for ones place. How many even digits do we have? 2, 4 and 6. It is 3. The digits are 2, 4 and 6. Yes or no? Therefore, after this we have to construct a table. 3 positions we have to construct for ones place, tens place and hundreds place. So this is the table. So this is ones place, then tens place, then hundreds place. Okay. So in the tens place, there is only one option left. That is what? We have to put only the even digits. So there are how many ways? As we are having 3 even digits in this given number of digits, we can put 3 options. Means once I can choose 2, once I can choose 4 and once I can choose 6. So any one of these 3 will be valid for ones place. So there are 3 possible options. Then after, it is mentioned that digits are repeated. Digits can be repeated. So do we have any restrictions for the tens and hundreds place? No, there is no restriction, and repetition of the digits is also allowed. So in total there are 6 options we have. Means these positions can be filled in with even numbers also or odd numbers also. Yes or no? So that is why 6 options are there for tens place. Then 6 options are also there for hundreds place. So we can write here what? The ones place can be filled in how many ways? 3 ways. Already we have chosen it. 3 ways. Then after, tens place can be filled in 6 ways. Then after, hundreds place can be filled in 6 ways. So after this, what do I get? After this, I get that one more thing to be added here. Ones place, tens place and hundreds place. All the 3 places are required here. Means ones place and tens place and hundreds place. So since the term and is required here in all the 3 cases, therefore fundamental principle of multiplication will be needed, and these 3 values will have to be multiplied for getting the total number of ways to frame the 3-digit numbers. Therefore, by fundamental principle of counting the total number of ways is equal to, of course, these 3 things we have to multiply. 3 into 6 into 6, and the result comes as 3 6 are 18, 18 6 are 108 ways. So this is the answer of question number 2. So here goes question number 3. In question number 3, let us see what it says. How many 4-letter codes can be formed using the first 10 letters of the English alphabet if no letter can be repeated? The first and foremost thing to be noticed here is no letter can be repeated. Means repetition is not allowed. 4-letter code we are to frame. That means there will be 4 positions where we have to fill in the letters of English alphabet. How many total letters are given? 10 letters are given to us. So the first thing that we need to write here is given total number of letters is equal to 10. To form a four letter code. Actually, to form 4-letter codes, it is not single one. We have to form 4-letter codes. So how many 4-letter codes? That time will decide, means when we shall be solving, things will be more clear. Then after, the most important point to be noted here is no letter can be repeated. So keeping this in our mind, we have to proceed. Okay, no letter can be repeated here. So after this, what I shall do, I need to consider 4 places where these letters can be filled in. So this is the first place, this is second place, this is third one, and this is the fourth one. Now already we have 10 letters in our hand. So for the first place, to fill in the first place, how many options do we have in our hand? Of course, 10 options. Any one of these 10 letters we can put here. So we can choose any letter out of these 10 letters. So of course 10 options are there in our hand. Since repetition is not allowed, no letter can be repeated. The letter which already I have put here, the same letter cannot be put in the second position. That is why, keeping that aside, how many options are left from here? 9 options are left, because already I have chosen one option for this first place. After that, already 2 places are filled in. Means one letter already we had put in first and second position. So in total 2 letters we have chosen out of these 10. So how many options will be left for this third part? 1 letter we have chosen for this first place, then another letter we have chosen for this second place, which we cannot repeat for the last 2 places. That is why, keeping those 2 letters aside, how many letters do we have in our hand now for filling up this place? Of course 8. Now 3 places already we had filled in. So how many options will be left behind for the fourth place? 3 letters we have to keep aside out of this 10. So how many will be left? 7 options are left in our hand. So we shall be putting in what way? Means the writing part. Place 1 is filled in how many ways? 10 ways. Then after, place 2 is filled in 9 ways. Then place 3 is filled in 8 ways. Then after, for the fourth place 4 is filled in 7 ways. Therefore, by fundamental principle of counting the total number of ways to fill in, or we can write to form 4-letter codes is equal to. Now Fundamental principle of counting. Which part do we have to use here? Of course multiplication, because none of these places we can ignore. This first place and second place and third place and fourth place. And means what? Fundamental principle of, the term n refers to fundamental principle of multiplication. So I can write here 10 into 9 into 8 into 7, and the result we get as 56. 8 7 ja 56 multiplied by 9. 56 multiplied by 9, it will be 4, 5 left, 504, then 5040. 5040 ways. So this is the answer for this question. So here goes question number 4. In question number 4, what is there? How many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each number starts with 67 and no digit appears more than once? The first and foremost thing that is to be noted here is the first two places should always be filled in with 6 and 7. In the first place there should always be 6, in the second place there should always be 7. And for the remaining 3 digits we have to make selections. Now what do we have? For the 3 positions, means how many 5-digit telephone numbers can be constructed, means in the telephone numbers there must always be 5 digits, out of which the first 2 digits should always be 6 and 7. This is fixed. In the remaining 3 positions, out of 5 digits, if the first 2 digits are already fixed, how many digits are left to be filled in? Of course 3. And the digits to be used here are 0 to 9. If each number starts with 67 and no digit appears more than once, means repetition is not allowed. No digit appears more than once means each digit we can use once only. So first of all, let us write down the given number of digits. The given digits are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So in total how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 digits in our hand. So total number of digits is equal to 10. Then after, what do we have to do? We have to construct a 5-digit telephone number. To construct a 5-digit telephone number. Which starts with 67. So let us frame the number. So these are the 5 places which we have to fill up. The first 2 places, means in this place we have to put 6, in this place we have to put 7. Remaining 3 places are left to be filled in. So how many options are there for the first place? This is place 1, this is place 2, this is 3, this is 4 and this is 5. For the first place there is only one option left, that is 6 and only 6 we have to put in the first place. For the second place I have to put only 7. That means only one option is given to us. For the remaining 3 places we can make arrangements. So here in this case, in total we have 10 digits, out of which 6 and 7 are already fixed for the first 2 positions. That means repetition is also not allowed. Therefore, we have to choose those digits what are not used in these two places. Means apart from 6 and 7, the rest of the digits we can choose for this third position. In total there are 10 digits, out of which we have to keep aside these two digits. So how many options are left in our hand? These options and last two options. Means in total how many? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 options left in our hand. So for the third place there are 8 options we are taking. Now the number, the digit which is used in this third place cannot be repeated for the fourth one. That means one more digit we are using for the third place. In total 3 digits we have to keep aside from this 10. So how many options do we have in our hand? For this place there are 7 options left, because from this 10 options, total of 10 options, we have to subtract these 3 options. Okay, because one more number we are going to put here. I'm going to put one more digit out of these 10 digits here. So 1, 2, 3. So in total how many digits are already used up? 3 digits. So out of 10, how many options are left in our hand? Of course 7 options for this place. So the number, the digit whatever is used in the fourth place also, that cannot be used further for this. Means these 4 options, these 4 numbers we cannot take for the fifth position. Therefore out of 10 how many options are left? Keeping aside these 4 options, in our hand there are 6 options left. Yes or no? So how to write it down? Ways to fill up. Ways to fill in place 1 is equal to, of course it is 1. Ways to fill in place 2, it is 1 again. Then ways to fill in place 3, it is 8. Then ways to fill in place 4, it is 7. Then after ways to fill in the fifth place, ways to fill in the fifth place is equal to 6. So what principle do we have to use here? Of course fundamental principle of counting. Which part? Addition or multiplication? Again multiplication we have to use, because none of these places we can ignore. All these 5 places we have to take into account. Means first place and second place and third place and fourth and fifth. This n stands for what? This n refers to fundamental principle of multiplication. So I have to write here, therefore by fundamental principle of multiplication, here I have to write, because it comes under fundamental principle of counting only. Therefore I have to write counting, fundamental principle of counting, the total number of ways. How do I write? Multiply 1 into 1 into 8 into 7 into 6. The result comes as, the result is 336, and that is your answer. So here goes question number 5. Let's check what the question says. A coin is tossed 3 times and the outcomes are recorded. How many possible outcomes are there? So actually this question, tossing of a coin, you already got in previous classes. In class 10. When we toss a coin, the possibilities of getting 2 outcomes we find. Actually the outcomes can be head or tail. So we shall be writing here when a coin is tossed, the possible outcomes are head and tail. So these are the outcomes we get when we toss a coin. Means either you will be getting head or you will be getting tail. Now in this case, since there are three tosses, the coin is tossed 3 times. So let's make 3 boxes for these 3 tosses. And the first box is for first toss. Second one is for second toss, and third one is for third toss. So when we toss a coin, the possible outcomes are what? Head and tail. So 2 options are there. Again, second time when we toss it, again there are possibilities of getting head and tail. Similarly, when we toss it for the third time, similar results will come, either head or tail. So actually both we have to consider, because head and tail both could be the outcomes. Either or means either head or tail will come, but in the sample space there will be both head and tail. So here I shall write the outcomes of the first toss is equal to 2. Then the outcomes of the second toss is again equal to 2. Then the outcomes of the third toss again comes as 2. So how do I write? I shall have to write in this way the final sentence. Actually, what principle do we have to use here? Of course, fundamental principle of counting. But fundamental principle of multiplication is particularly used here, because we cannot ignore any one of these tosses. Means all the 3 tosses will have to be taken into consideration. First toss plus second toss plus third toss means first toss and second toss and third toss. This means what? And means what? Multiplication. By fundamental principle of counting, the possible outcomes are what will it be? These 3 quantities we have to multiply. 2 into 2 into 2, the result is 8, and this is the answer. Here goes question number 6. The question is given 5 flags of different colors. Actually, all the 5 flags are of different colors. How many different signals can be generated if each signal requires the use of 2 flags, one below the other? Now, if we go through the question, nowhere it is mentioned that repetition is allowed or not allowed. That we have to find out ourselves. So first of all, let us write down what are the informations given. Given number of flags is equal to 5. Then after, each signal requires the use of 2 flags. Now one thing can be noticed here, that different signals has to be generated. Different signals are to be generated if each signal requires the use of 2 flags. if suppose one below the other, I consider, say, this is the first flag, this is the second flag. So this is the way I'm arranging it. First flag, this is first flag, this is second flag. If I put same color to first part and the second part, I mean if both the flags are of the same color, do you think it will represent any signal? No. It is necessary that for different signals, the color of the flags, upper one and the lower one, both should not be of the same color. Both should be of different colors so that they can represent any signal. Therefore, in this case, what does it mean? If we cannot use the same color for both the flags, I mean if both the flags should not be of same color, what does it mean? Repetition is not allowed. That means yes or no. So it is well understood from the question itself that repetition of same colored flag is not allowed. So how we shall be writing? There are how many possible ways to fill up the upper part? In total we had 5 flags. Each signal requires a use of 2 flags. That is why 2 flags we are arranging here. This is upper part, and this is the lower part, and both the parts should be of different colors, because if both of them are of the same color, it will not represent any signal. Therefore, it is must that both the flags should be of different colors. So, how many possible ways to fill up the upper part? I mean, the upper flag could be of. How many options are there to fill in the upper flag part? Of course, there are 5 options. So we can put 5 here. Since repetition is not allowed, therefore lower part can be filled in 4 ways, because one option we had already left for this upper part. So keeping that aside, how many options are left? Of course 4 options are left here. So how we shall write it? The reason should we give here? Yes, of course. How we shall write? If both the flags are of the same color, actually it will not represent any signal properly. This implies that repetition of colors is not allowed. Repetition of colors is not allowed. After that, what we need to write? Let's come to the calculation part. So for calculation, what do we have to write? The upper part can be filled in how many ways? 5 ways. The lower part can be filled in 4 ways. Now none of the parts we can ignore. Therefore, we have to apply here fundamental principle of multiplication. So it will be, therefore, the total number of possible ways is equal to 5 into 4 is equal to 20. So this is the question, solution of the last question of this exercise. So with this we end up exercise 7.1. Thank you.